phones, etc. So please go ahead and do that if you've not already done that. Welcome to this session. So let me advance the clicker here. This session is about monitoring, management, and DevOps in Windows Azure. My name is Chandrika Shankar Narayan. I'm a PM, Program Manager Lead in the Windows Azure Management and Monitoring Platform Group. And with me is Stephen Siciliano, who's a Program Manager also in the same group, working on some of the cool features that were actually released at Build this week. You may have seen at the keynote demo that Satya did on autoscale, and that's one of the features that Stephen's working on. So we'll be talking a lot about some of the cool features we released at Build, including alerting, notifications, and autoscale, and demoing them extensively in this session as well. So before we go into the session, I want to know how many of you folks are actually already using Windows Azure? That's a lot of you in the room.
Awesome.
How many of you folks are actually using Windows Azure Management Portal to manage your applications? That's a handful, so that's good to know. So we'll spend a bunch of time talking through the Windows Azure management capabilities as well in the management portal itself and the management portal architecture so that you have a good understanding coming out of this session, hopefully, about how the Windows Azure Management Platform works, and hopefully we'll start using the Windows Azure Management Portal and maybe give us some feedback on some of the requirements that you may have on the management platform itself. So today we'll talk a little bit about the overview, about what we're trying to achieve with the management and monitoring platform, and we'll spend the bulk of the session on demos. So you'll see a series of demos in the management portal on management, as well as a lot of demos on the monitoring side of the house as well. We'll talk a little bit about the architecture behind what lies behind the management portal and the monitoring infrastructure. And of course, take a lot of questions. In summary, we are in the process of doing a lot of work in the management and monitoring platform and taking some of the APIs public. So this is a really good forum for us to get some feedback from you as to missing features or enhancements to existing features, etc. So this is hopefully a familiar slide you've seen at the keynote, as well as maybe some of the sessions you've seen over the last couple days. But I want to set the stage without spending too much time on what it is that we're trying to do here in terms of the management platform and where it fits in the overall platform of Windows Azure. So you've heard probably time and time again over the course of the last couple of days that the trend that we're seeing, most of you developers, most organizations are building applications that target 3 or more platforms today. Applications that are web-based, applications that are targeted at the server, and applications that target more than one device, whether it's a tablet or a mobile device, etc. So therefore, you have a need for heavy compute, whether it's control over your infrastructure or really high flexibility and enterprise grade for building web applications, media services, mobile services, or cloud applications. So our compute platform, starting with the highest control over infrastructure with IaaS, all the way through degrees of control and flexibility through cloud applications, websites, mobile services, and media services are available today already on the Windows Azure platform. And most of these services are GA already, generally available. Now, on top of these services, in order to build the enterprise class applications, you need additional support for services that provide ancillary help, such as integration services, BizTalk services for integration, connectivity services such as Service Bus, notification hubs, data services such as SQL Azure, obviously, NoSQL tables, blob storage, HD Insight. You already had a session yesterday or maybe coming up later this afternoon on HD Insight as well. And of course, for governance and security, Active Directory, 2FA, multi-factor authentication, access control, etc. Now, none of this is obviously very productive if we did not have a great programming model and a set of tools for you to build these set of cloud applications on. So with .NET and Visual Studio, we provide you with a rich set of tools and programming model, not just for .NET, but also the flexibility for non-.NET platform, such as Java, Node.js, PHP, Python, Ruby, etc. Again, on the runtime side of the house, we are providing you with a great management platform and flexibility for monitoring the slew of Windows Azure services and applications that you build, not just on the Windows Azure platform, but we're also looking cross-platform as well. So if you had an application that crossed both Windows Azure platform as well as, say, AWS, we want to be able to give you the ability to monitor the heterogeneous application. Now, how do we do this? Obviously, you have the rich set of services that are available to you in the Windows Azure platform. Now, there is a unified set of APIs called the REST management APIs that we provide to manage all of that, sit on top of all of these different disparate resources, if you will, or services, if you will. And you could be writing these applications that are targeted at Windows or Mac or Linux, and all of these things sit on top of the same unified management head. And you could be using any kind of client, whether it's browser-based, which is Windows Azure Management Portal, or any other third-party tool that you may have built on the same REST API, or command line tools, or PowerShell. We'll talk a little bit more about the architecture that sits behind the Windows Azure Management Portal, but before we do that, let's actually dive into the demo itself and walk you through some of the capabilities in the Windows Azure Management Portal. So let's switch into the Management Portal. So those of you that have used the Windows Azure Management Portal are already familiar with this view, but for those of you that aren't, I want to make sure we talk a little bit more about the principles behind the portal, some of the navigation paradigms, some of the consistency we provide across all of the different Windows Azure resources. So you'll see on the left-hand side, we have a slew of resources that are provided, that are supported on the Windows Azure Management Platform. Websites, virtual machines, mobile services, cloud services, all the way down to networks, Active Directory, etc. We have a single pane of glass to manage every one of these services that you may have deployed on Windows Azure. Now, your view at the center pane here, the All Items view, is a heterogeneous view that provides you a list of all of these services that you've deployed, what type of service it is, where it's deployed, what its status is, what subscription you're using for deploying these services. The command bar at the bottom, as you can see, manage access keys, delete, etc. These are commands that are available depending on which service you're using to richly manage the individual service. Notice up here that we have a subscription filter. We've heard from most Azure customers that they have definitely more than one subscription that they're managing at any given point in time, and roughly 1 to 2 subscription. The long tail goes all the way to 150, 200, sometimes 300 subscriptions. So the feedback we've gotten from customers is, please give us a way to filter our subscriptions, because otherwise it's going to be a nightmare for us to manage the set of services we have on Windows Azure. So this is a capability that allows you to filter the subscriptions you have such that you can entirely filter out the portal to the subscription that you want to look at. So in this case, we have 2 subscriptions, Azure Demo and Free Trial. So I'm going to filter this out so that I can only look at Azure Demo ever. So what this does is it reloads the portal, reloads all the services that you have deployed to that single filter that you want to look at. So now I'll be looking at Azure Demo through the entire portal. Whatever I'm managing within the portal will be restricted to Azure Demo subscription. So now subscription filter is applied. Now I'm looking at the lens of the entire portal through Azure Demo. So I'm now filtered to a few subscriptions. I could go to now the settings tab here, and it's sometimes not discoverable. We're trying to figure out how we make this more discoverable. I have a slew of common services that are provided across all Azure services. We'll spend a lot of time on the alerts view, so I won't spend too much time on it right now. But what this does is gives you the ability to look at all alerts that you may have configured. And this is the new feature we just released at Build, hot off the press, which gives you the ability to configure alert rules over the health metrics that you have coming out of each of the Azure resources, either defined by yourself, such as custom metrics, or emitted by the platform itself. So you can define alert rules and look at the health of those alert rules, whether they're triggered or not, dive deep into the alert history, look at when they were triggered, etc. And you can also configure notifications. We'll go into that in a little bit. The next thing is management certificates. So most of you folks have more than one management certificate, as we know. We've actually increased the number of management certificates now to 100. It used to be 10. So hopefully most of you folks are happy that the limit has gone up. So you can manage all of your management certificates here, upload new ones, delete, etc. Administrators allows you to manage your co-admins. You can add co-admins to your SA account. Operation logs is a capability that helps you look at operation history of all of the operations you performed in the management portal. So whether it's through an API or through the UI itself, you can look at what the operation ID is, what the status of that operation is, who performed the operation, and on what service you perform the operation. One of the things we're trying to do is, in order to help you troubleshoot hotspots in your application, this becomes a very important pivot, and this will be available through the API too, but right now it's only available through the portal. What this gives you is the ability to troubleshoot through the course of your running application on a given service who performed what, and then go into detailed error logs based on a specific operation that was performed. Today, this is only supported for cloud services and storage. We will be adding more and more services into this capability such that you will see operation logs across every single service that's supported in Windows Azure. Going back to all items, let's dive into websites. One of the things that I want to show is the consistency across the different services we have in Azure. The new capability, the Create New drawer allows you to create some of these services very quickly. Notice that we have categorized all of our services under 4 distinct categories: compute, data, app services, and networks. And we provide a consistent provisioning experience across all of these services. If you're a new user who's new to Azure and wants to test out Azure services, you can quickly create services using the Quick Create option, which has pretty much 0 configuration. You can get started very quickly. Of course, if you're an advanced user and you're already used to building complex applications, or you're building more than one service that you want to provision at the same time, custom create or other sorts of complex creation experiences allow you to create these services in the familiar way that you want to. And this paradigm translates to every single service we have within Windows Azure. So there's consistency across services and familiarity that you already have from having managed a given service in Windows Azure. Let's dive into a given website. Let's pick Build Demo Website. Notice that the first thing you see is a Quick Start tab, which gives you the ability to quickly get started on Windows Azure, whether it's installing the SDK, publishing your application, integrating with source control. And this depends on the technology you're using. If you're in a cloud service, you might get a different type of guidance within Quick Start tab. But this is consistent across every service, which is the thing we're trying to achieve. The dashboard gives you the ability to look at a glance, all of the data you want to see, whether it's health, certain set of metadata that's important at runtime, certain specific configuration that you want to do at runtime, all of that information all contained within a single pane of glass. So what you'll see first thing is a graph, a dashboard graph that gives you out-of-box performance counter metrics. Now, at any given point in time, you can see 6 metrics on a dashboard, but you can do configuration to see what you want to show on the dashboard if you go to the Monitor tab. That gives you additional customization. There are things like endpoint status. If you had configured outside-in monitoring on your website, which is also another preview feature that was released a couple months ago, and web endpoint monitoring is available for all compute services as well. So you can configure web endpoint monitoring, and you can look at the status of that endpoint configuration right here. You can also look at autoscale status, and we'll spend a bunch of time on autoscaling later on in the demo. You can look at usage overview, depending on what billing meters are being emitted by that particular resource and your usage consumption of that particular resource. You can look at usage overview of that resource right here. Linked resources gives you an interesting view over other services that you may have linked to this given service. In this case, this build website demo, I'm using a MySQL database to provision with. I have a connection string to that database. So you're able to see all of the linked resources right here in this view. Of course, you can drill in and look at interesting data on that linked resource as well, which gives you richer data on that pivot. Quick Glance gives you some quick glance properties: status of my application, URLs, the compute mode I'm running in, if I have diagnostics logs configured, the link to download diagnostics logs, etc. There's also other interesting things that you can do with the Quick Glance property, and this is a very standard paradigm across every single Azure service. So you'll see the same thing cutting across every service. My Monitor tab, as I said, gives me some richer experiences. I can add metrics. If I had custom metrics, for example, that I'd instrumented in my application, I can add those metrics to my list and then have them exposed in the chart. And then I can look at different scales, whether it's relative or absolute. I can look at different time windows, whether I want a 24-hour window, 6-hour window, etc. And it depends what I'm trying to look at, what I'm trying to troubleshoot while managing my application. Configuration is essentially the runtime configuration metadata that I want to edit at runtime. There's things like SSL certificates, things like custom domains I may want to add for my website, deployments, application diagnostics configuration, etc. I won't spend too much time on the Scale tab because we will be spending a lot of time on autoscaling later on in the demo. So let's go back. And this particular paradigm, as I said, transitions. If I go to virtual machines and pick a virtual machine, I'll see the same type of paradigm that runs through. One thing I want to point out, one of the common scenarios for DevOps is managing your source code control. So we have provided the ability to configure source control, rich source control, not just our own Microsoft-based TFS, but also Git and Mercurial, Dropbox, etc. for websites. I can configure, for example, websites using very simple steps. If I were to build a simple build demo website, let's not complicate it and add a database, but let's simply publish from source control. Notice that I have the ability to pick from different types of source control. Team Foundation Service is Microsoft's source control system. If I have a local Git repository, I can use that, or if I'm pushing my sources from GitHub, Dropbox, Bitbucket, etc. So if I pick one, the next option I get is to configure my master repository. In this case, I'm going to go ahead and get authorized for the specific repository I'm using. I have actually a website that's already configured for it while we're waiting for this. Oh, there you go. So I'm using Windows Azure Demo repository that I've already configured. It authorized me immediately, so my authorization was successful. It's picking that as my master repository, and I can go ahead and deploy this website. So momentarily, this website will get deployed, and I have my sources being pushed from GitHub. And I can go ahead now. Let's actually dive into the build demo site and go to my deployments tab. As I dive into this, notice that I already have an active deployment. I also had made a small change in my deployment earlier, right before this demo. So I've updated a README file here, and notice that I already have an active deployment and a previous deployment. I can swap deployments if I wanted to right now. So this gives you a full view of your entire set of deployments, and you can look at who did what and when and manage your deployments very easily. So with that, I'll actually transition over to the slides to talk about what's behind the scenes as far as the management platform is concerned. So what's behind the scenes really is a unified REST management API. This is the public API that's already available to all of you. Acts as a proxy to all of the individual services that you see on Windows Azure, whether it's websites, cloud services, IaaS, all of the first-party services that are supported on the Microsoft platform, as well as third-party services. One thing that I did not demo, and we'll try to see if we can get to it at the end of this talk, is the ability to have third-party services reflected in the management portal and manage them through the management portal. So we have a Azure store, if you have not already looked at it, that allows us to allows users to purchase third-party services on Windows Azure and directly be able to manage your application using that service from within the management portal, or link to that particular service's custom portal or custom management experience as well. So we'll do a demo very quickly at the end if we have time. But essentially, the architecture remains the same, whether you're a first-party Microsoft service or a third-party service. So every call goes through the unified management proxy. The unified management proxy also acts as a batching layer and also a security boundary. Now, the management portal sits on top, management portal or any client for that matter, sits on top of this unified REST. And there's obviously a ton of extensibility within the management portal too. And we'll again try to see if we can demo that later. So we have extensions that we've built within the portal for all the first-party services. And this is not just the Windows Azure group, but also across Microsoft. Some of the services you see on the left navigation in the management portal are not necessarily built by the Windows Azure group within Microsoft, but across Microsoft, other groups within Microsoft. So you can imagine similarly third-party extensions coming in and extending the management portal itself to build rich management experiences as long as they're sitting underneath the unified REST. The same capabilities available also through PowerShell and scripting as well. There's a slew of horizontal services that I want to talk about a little bit that help make the management experience pretty rich. The first thing is the application manager. What that does is allows us to compose one or more services and manage the lifecycle of that application. So we saw in this example a website and a database that I deployed. Now, I had a connection string to that database from my website. So the application manager API essentially provisions the two services at the same time and manages the lifecycle of that connection and persists that connection string essentially. So if I were to delete the website or the database for that matter, it tells me, hey, there is a website that's using your database. You may want to not delete it at this time or consider making some code changes in your website. So the composite lifecycle management is done by the application manager. The billing layer is obviously a fairly thin layer. There's a billing backend that backs all of the the wonderful billing capabilities you get on Windows Azure. But the REST management acts as a proxy to get the billing data that's surfaced in the portal. What you saw on the dashboard for usage information and things like that are surfaced through the billing backend. The monitoring API, which we'll talk about in great detail later on, sits as a sort of a shim on top of all of the individual services to get rich metrics, rich alerting information, auto-scale information, diagnostics information, et cetera, and surface it up through any client that wants to consume it. So the unified management REST simply acts as a proxy. The bulk of the work is done by the the monitoring API. Marketplace is obviously another shim that allows you to have a marketplace experience, if you will, that allows end users to create interesting applications using out-of-box templates. So you'll see a website gallery that we support. You'll see a VM gallery as well. And of course, ultimately, the Azure store, which will be using the marketplace set of APIs. So essentially managing the life cycle of your application, whether it's deployment and provisioning, upgrading, configuring, monitoring, billing, subscription management, and marketplace management. All of this is handled by the individual horizontal services that sit underneath the unified REST API, which is what we expose publicly for users to access, as well as client tools to access as well. Now with that, let's actually dive into the monitoring capabilities. We'll start by switching to a demo, a series of demos, and then come back to the architecture. So one thing to keep in mind is we just previewed availability, alerting, and autoscale capabilities, which we will demo quite a bit. But this is in preview, so if you've not already used it in the last couple of days, please go ahead and start using them. Oops. Switch back.
Thanks. So that's a great background. I'm going to actually show some of these features working live. So you come to the website here. Chandrika mentioned that we have monitoring. If you click on this for the outside-in monitoring, what you can see is we have 3 different endpoints that are pinging this website that I've created. Now, this allows you to see how it responds across the world, and you can actually see this table below contains details on when you pinged the website and what the response time was. Now, it's relatively easy to set this up, so I'm going to set this up for a cloud service now. I have this T-shirt app that I'm working on, and when I come to the dashboard, you can see I have a link to configure endpoint monitoring. Now, endpoint monitoring is just on the Configure tab, so if you don't see that link, you can just click on Configure. So I'm going to create 2 different tests. So you choose the locations that the tests come from and the URL. So I'm going to do this, home 2. These will show up on the dashboard. It takes a little while to actually ping the website. So I'm going to configure this, and if you go back to the dashboard, it'll take a little while to show up here. Now, it's useful to see the status in the dashboard, but what you really want is to be informed if something actually goes wrong with your website. So we've created the new alerting functionality. So if I create an alert for this function, we have alert 1. You can name it whatever you want, and I'm going to create it for the build demo website. I want to be informed when the response time is slow. We show all of the metrics for the ping capability that we have. So I'm just going to choose response time from Ireland. And I want it when response time is greater than 200 milliseconds. So you can see the unit indicates seconds, so I need to do 0.2. We do an average over a certain amount of time. We default to 15 minutes. And then you can choose how to be informed when this alert gets triggered. So when my response time is slow, what happens? Well, we can, by default, just send it to all of the SAs and co-admins. But if you have maybe PagerDuty set up and you want an email gateway for that, or you have an alias that supports your service, or you just want to enter an SMS gateway, you can do that here. So I'm going to enter my Microsoft email and enable the rule. So as this gets created, it's going to take a little while to go through the alerting system. But I'll come back a little later and we'll see if this actually shows up in my inbox. So that's alerting. And actually, I think you saw something change there. You see, this alert actually went active. So when something goes wrong, it shows up as active here. And you also get a toast at the bottom indicating that there's 1 or more active alerts. So yeah. but I'll come back to alerting once the new alert I created fires. So moving on down the page for cloud services, you can see the new section called autoscale status. So autoscale, as you've probably heard, maybe not, allows us to dynamically adjust the capacity of your website or cloud service or virtual machines availability set as the load on it changes. This just links you directly to the Scale tab. We've completely revised the experience for the Scale tab. It will list the roles and allow me to configure my autoscale rules on a per role basis. Since each role probably has different load characteristics, different things are happening to it. So for this deployment, I have 2 roles set up. I have a web role and a worker role. The web role is going to be CPU driven. So I want to set up autoscale by CPU for this. When you set up autoscale for CPU, you're going to get 2 ranges. And actually, I'm going to save this just so that way it takes effect sooner. But you get 2 ranges. The most important thing is setting the instance range. You set a minimum and maximum number of instances that you want us to scale between, and we will never exceed or go below this. So if you put a hard minimum at 2, we will never turn off your machines such that you have 1 instance. Setting that minimum is important because if you want high availability with your cloud service, we generally recommend that you say 2 instances. At the upper end, we let you set the cap because you may want not to spend more than a certain amount per month. In that case, if my budget is to spend $50 a month and an extra small VM costs $10, then I'm going to put a cap of 5. So the way target CPU works is when the average CPU across all of the instances in my role drops below or goes above this range, we will take a scale action. So we don't look at individual instances, we look at the aggregate. So that means if you have 1 instance that's misbehaving, we won't necessarily pick that up. But on average, if you have a good load balancer and the load is evenly distributed, we will detect that and we will add instances to take that additional load that you're seeing. The other functionality that we have scale by today is for queue. So I'm going to turn that on here. When you set up scale by queue, you get to choose the queue, obviously. It wouldn't be very useful if you couldn't. Queues all live in storage accounts, and then I have my orders queue. And then the target per machine, what this means is there's a certain number of items in your queue, right? So let's say you have 300 items at any given point in time. If you know that 1 machine can handle 300 items, then you can put 300 here. I'm going to say 150. So this means that my worker, I've done some perf analysis, and I think that each worker role or each worker instance can handle 150 items in the queue. So just to prove that this actually works, I have the orders queue here. You can see there's currently 0 items in it. So I'm going to insert 255 items. So I set a target of 150. So this means what should happen once this all goes in is I should get at least 2 instances of the worker role to handle these additional items that are coming into my queue. Now, I'm going to move on to virtual machines because we also support autoscale for that. So for virtual machines, there's something a little different. We don't have the ability to provision additional new virtual machines. For platform as a service, cloud services, we can do that relatively easily because we know exactly how to deploy. But for virtual machines, we don't know what configuration you set up. We don't know what specific parameters you have in order to create the application on a virtual machine. So we do require that you start the virtual machines that you need at what you think your maximum will be. So if you think that you only ever need 6 VMs to handle your load, we do require that you go in, you create 6 virtual machines, you provision them, and that you add them to an availability set. So this availability set here, my test boxes, contains all the virtual machines that I want to autoscale. Now my CPU is low on these, so right now I have 2 running, and what you're going to see after I turn this on is eventually it'll scale down to 1. The maximum on this slider is 2 because I only have 2 deployed. If I want more virtual machines, I'm going to have to create them manually and add them to the availability set. When you create the virtual machines, you have to specifically put them behind the URL for all the machines you want to load balance across. So you can see here the Geek Quiz text boxes. That's the DNS. You can't do this after the fact. So once you create the VM, it's going to be stuck there. However, you can configure it to to move into the availability set. So if I created a few more virtual machines that I wanted to autoscale separately, I could move them into a different availability set here. You may have noticed that I haven't actually showed you if autoscale works yet. The reason for that is because it takes a little while to take effect. For CPU, we actually average the CPU across a 60-minute running window for your service. So if I go into the T-shirt configuration, I go to monitor, what you'll see here is this is an hour chart. So this represents how we are going to determine what the load is for your cloud service. Here you can see 90% CPU for my worker role, or for my web role. So that means it's well above the 80% threshold that I configured. So this should scale up, but it takes a little while to take effect. Likewise, you can see the specific value in the table here. So this exact value is the one that we'll be using our threshold, because you can see this is an average not only across the time window, but also across all of your machines. So it's kind of a two-way average. Now, the CPU is very low on my worker role, but because I configured it to scale by queue, it should also scale up. So we also have autoscale for websites. So if I go to a website, I can go to that same build demo website that I had earlier and click on the autoscale status section. Now, you may notice that there's a little upsell here. It says, hey, autoscale can save you 50%. We determine this by looking at the CPU usage for your service and the current number of instances that you have running. So if I currently have, I think I have 2 instances running here, and my CPU is actually really low, that means I can safely scale down to 1. However, I'm already going to show scale down on virtual machines, so I'm going to actually show something slightly different here. When you enable the scale by CPU, you get this range. We will scale you directly into that range. It doesn't matter if you go from 1 to 5 or 1 to 10. Since we respect this capacity so specifically, this means I'm going to scale directly from 2 to 5. So I'll show that working well. Now, you may have noticed that there's fewer controls on this page than on the previous page. That's because for websites, the way it works is we will scale up every 5 minutes if your CPU stays high. We will scale down once every 2 hours to prevent you from losing your capacity that you need. We do give you, though, this exact control in the cloud service. So if I go back to the Scale tab, you can see that we will have controls that allow you to set the step up and step down for the cloud service. Setting a step up is very useful if you have a lot of different instances deployed. Say if I have a role with 50 instances. I don't want to step up by 1 instance at a time. It would take forever to get to the cap for my role. So I can say scale up by 6 instances at a time. Likewise, if you want to adjust the speed at which it happens, you can adjust the wait time here. Now, an important note about wait time is we don't take a scale action while your role is currently in a transitioning state. So if I previously took a scale action 3 minutes ago, I'm not going to take a scale action right now. If I previously took a scale action 5 minutes ago, but it's still deploying that new role, I still won't take a scale action, even though I put my wait time at 5 minutes. So what this can mean is it can be 10 or 15 minutes between scale actions for your cloud service if it takes a while for your service to deploy. Cool. So for the cloud services, we support this capability, and we also support it for virtual machines. Likewise, we have a separate scale down capability, which is I can scale up at a different rate than I scale down. So this is very useful if I want to, say, handle a lot of aggressive incoming load, and then I want to slowly taper off the number of machines over time. So what we find very frequently is people will put this number, say, at 2, put this at 10 minutes, but then put the scale down by at 20 minutes or at 1. So that way I don't just remove a bunch of resources that I've just recently provisioned. Now, a nice thing about virtual machines, though, is we bill per the minute. So that means if I say turn on a virtual machine for 30 minutes and then I turn it off again, I'm actually only billed for half the hour. For configuring all of this, it just takes a few minutes, and it works pretty easily. So you see here, it's actually already started scaling up. So my web role now has 3 extra small instances. If you remember, it started at 1. Now, the reason it has 3 is because I set my, if I discard this, I set my scale up by to 2 instances. Now, the worker role, it has 1 because I set my scale up step by 1 instance at a time. Now, you can come here and you can kind of look at what you have. But if you also want to get a history of the actions, you can go to the ops logs that Chandrika mentioned earlier. So ops logs will show the history of the actions taken by autoscale. And you can see here that it started operation at 12:31 and finished the operation at 12:34. So the caller here is listed as not available. That means it was taken by the autoscale engine. Generally, the caller is going to be the person that came to the portal and manually changed your settings. But if you ever want to identify all the actions taken by autoscale, you can just search for not available. And we'll update that text. So maybe it says autoscale or something like that. So it's a little bit clearer. But yeah, so this is a good way to view the history of actions taken for the cloud service. Now, I'm going to jump on to a different topic while I wait for all the other autoscale actions to take. You can see this is in a transitioning state. So if I come back to the cloud service, Chandrika mentioned that you have the ability to have custom metrics. So this is a very high demand feature. You often have specific perf counters inside your application that you want to record and show alongside your other metrics in your dashboard. So we have the ability to insert them in the chart here. So I'm going to show you exactly how this worked. So I have this project open in Visual Studio. I have the web role. So the first thing you have to do is you have to use the system.diagnostics. So that imports the perf counter libraries. Then you, in the webrole.cs file at the role entry point, you're going to create the perf counter category. So categories are just groupings of perf counters. You can call it whatever you want, and it'll show up kind of together in the portal. So it's just a small snippet of code. All this is also in help topics. You don't need to try to take notes or anything. But basically, if you put this at the role entry point, then all you need to do when you go to the specific place you want to log the perf counter is just create a new perf counter and increment it. In this case, I increment by 50, just so that way it shows up more on the chart. But you can see how easy it is to do this. Now, there's two other things you're going to have to do to make sure that they actually show up. So, applications can log hundreds or thousands of perf counters potentially. We won't necessarily pull all of them and put them in the charts. So first, you have to make sure that the role is running as elevated. And second, you need to turn on verbose monitoring. So I've already turned it on for this cloud service here, but I'll show you exactly where it is. It's just this button here. We would recommend that you instrument all of your stuff and then turn on verbose. That will make sure that everything gets picked up. But once you turn on verbose monitoring, it will show up in the list of all of the metrics that appear in the chart here. So if I click on Add Metrics, you can see not only are there the custom performance counter that you saw in the sample, but there's also a bunch of other perf counters that we've added when you turn on verbose monitoring. So you get ASP.NET application requests, you get web service requests, all that stuff. So when you turn on verbose monitoring, it's a really great way to get more detail about what's happening to help you debug and run your cloud service. So I'm going to go back to the alerts and see if anything actually fired. Yeah, so for this alert, I'm going to show you exactly what it looks like when it is fired. The way it works is we show a chart at the top that indicates the metric that you care about, and a line at the bottom that indicates the threshold that you've established. So for this alert, it's a bit impractical to think I'm going to have 20 millisecond response time from Hong Kong, but at least it shows up for the demo here. This history will populate as time goes on. So if I have an alert that's running for a week or a month, it will show me every single time that this alert was triggered and when the alert was no longer triggered. So if my response time then falls back below a reasonable threshold, it'll say it's resolved here. We also show a little summary saying, how frequently has this happened in the past day, in the past 20, or in the past 7 days, and such. Now, this is primarily useful because, hey, you want to be able to inform via email when this alert comes in. So I'm going to show you, this is the response time that I added, the 200 milliseconds from Ireland. You can see the alert showed up in my inbox 3 minutes ago now. And so you can see kind of the lag time it takes for the alert to appear. But here's the thing I get in my inbox. It shows me some basic details about the alert. And something to keep in mind is we will tell you when the alert is activated and also when the alert is resolved. So that way, if you're just sitting on your email, you'll see something come in, say, oh, something's wrong, and then a few minutes later, you may see a resolution. You may know that you don't have to do anything, but you probably should still fix something somewhere if you're getting a bunch of alerts like that. So I'm going to go back here and see if the website auto-scaled. It's easier to go here. Also, the alerts do show up on the individual resource page. So this is the alert for the website. So you can see it shows up here. And that link just takes you directly to the alert page that you had previously. So you can see it scaled me to 5 instances. So auto-scale functions for websites as well. So there's one other cool feature that we want to share for websites, and that's website diagnostics. So Chandrika is going to demo that right now.
Thank you, Stephen. So you saw a lot of rich monitoring capabilities in the portal, and this is not where we stop. We're still previewing alerting and auto-scale. There's a bunch more work we need to do as we move forward and to make the API publicly available to you so that all of this kind of goodness that you're getting in the portal is also available to you via the APIs. The thing that I want to show is round out the picture and show you some capabilities we have for diagnostics. So let's pick website diagnostics, and let's pick this website called Streaming Logs. So diagnostics today is available to you to set up. Let's actually go to the configure tab so it's easy to understand. So we have traditionally provided you capability to do site diagnostics for websites. You can configure web server logging, detailed error messages, and failed request logging. This is available to you. This is pushed to the website file system storage and available to you through access through FTP or FTPS. So you can go to the dashboard, for example, and download those log files with specific deployment credentials that you may have set up. So if I go down here, my FTP and FTPS diagnostics files are available to me for download. One thing that we've made available now is the ability to configure application diagnostics. So if you have instrumented your application to emit system.diagnostics traces, you can enable them here. You can turn them on for application logging. By default, these logs are going to be stored in the website file system storage, which means they're accessible to you through FTP or FTPS, so you can download those log files. However, you may want to push them to your own storage account, so we'll give you the ability to push it to down here, as you can see. You can push that to your application logging storage account, which means you pick the storage account you want to push the logs to, and then you can do any kind of analysis you want with it. The one thing that's cool that we've added more recently is the ability to stream these logs that you've pushed to either the file system storage or diagnostic storage, to be able to stream them real time to do real-time debugging. So let's actually try and do that. So here I have a command window, and I'm going to go ahead. Well, I have my application logging turned on, for one. The second thing I needed to have made sure is that my logging level is turned on to verbose. So that is already done. This configuration is saved. Let's go back to the dashboard of the website. And I'm going to minimize this so we can see both of them at the same time here. So here I have my website, which is running. I have my command window. Today, the streaming log real-time log capability is available only through command line tools. We will make them available in the portal as well shortly here. So what I'm going to do is go ahead and kick this off. Azure site, log tail, and then the name of the site, which is called Streaming Logs. I'm going to kick this off. While this is coming up, let's just scroll this over. So it's actually starting the process. So I'm going to go ahead and hit the website. I've actually simulated an error so you can actually see the traces coming through. So let's go ahead and hit the website URL. So the next thing you should see is that my home page was accessed. And I'm going to go ahead and simulate an error here, and you'll start to see error traces coming through the streaming log window. So you can imagine that I might be wanting to debug the various different sites within my web application and be able to see the error traces coming through real time through Streaming Logs engine. So this is obviously only available through CLI today, but we will make that available through the portal itself, so you don't have to bring up a command line window to see this capability. Now, diagnostics capabilities in general are available for other Azure resources as well. You can set up diagnostics logs to be configured for cloud services as well as storage accounts. One thing I failed to mention is for websites, this is not just for application traces. You may be wanting to stream your IIS logs, or custom logs as well. As long as they're sitting in some FTPS location and stored in the file system storage, we should be able to stream them real-time for you for real-time debugging. So now let's switch back to the slides to kind of go over what is behind underneath the hood as far as this monitoring stack is concerned. So here's a little bit of a component diagram that shows you what lies behind the monitoring API. So we have a unified monitoring API, which is not public today. And in the management diagram, you saw that the monitoring API sits kind of behind the unified REST management API. And the unified REST management API simply proxies to this. The bulk of the work is done by the monitoring API. What sits behind this is a set of APIs that give you some rich monitoring capability. The Query Metrics API essentially gives you health metrics across all of the Azure resources. So whether you're a website or a cloud service or a VM, or even a third-party service, you want to push specific performance counter metrics. As long as you're conforming to the interfaces we publish, we should be able to provide those health metrics that you see in the dashboard and the monitor page. Also, custom metrics will come through some of the same pipeline. Availability metrics that you saw, the outside-in pinging, comes from another service. However, it comes through the same pipeline that allows us to stream the same set of metrics, availability metrics, through the unified monitoring API. These metrics, health metrics, also act as data sources for other capabilities, for setting up rules, for example. All of the alerting rules that you saw Stephen demo, they can be done over all compute resources today as they're available in preview. And can be configured for all of your health metrics for those 4 compute resources, as well as availability metrics. So we have a rule store to persist the rules in, a rule evaluation engine that does the processing of those rules, and then takes action on what specific thing you need to do based on triggering of that rule. Today, in the preview, we only support email. In the future, we want to be able to support SMS, as well as push notifications to devices as well. So the data sources, we perform those rule operations over those data sources and be able to surface alerting capabilities, alerting notifications in the portal, and auto-scaling rules as well, and auto-scaling configuration and auto-scale capability in the portal as well. All of that, again, pipes through the same unified REST management API. Now, diagnostics. Today, we have disparate diagnostic sources, and we kind of do one resource at a time. But where we are moving towards is to be able to have sort of a basic or a common schema, if you will, of across all of the different disparate diagnostic sources, push the diagnostics data into a common storage account, whether it's your as in customer storage account or the platform storage account, and be able to perform interesting analysis over those. So we are working to build such a capability through the API, as well as provide some rich capabilities in the portal, management portal UI as well. So that comes, again, through the same pipeline. We want to be able to provide diagnostics APIs through a single endpoint for you to be able to access as well. The interesting thing there is, the data source exists in a storage account that may be accessible to you. However, the interesting thing is to be able to go cross resources. If you're operating over websites, databases, cloud services, virtual machines, etc., to be able to give the rich diagnostics capabilities through one single pipe, and maybe even to be able to do event correlation across these, depending on how complex your application is. The next thing that I want to talk about is the event notification service. Today, again, the event notification simply focuses on sending email notifications when you have alerts configured, alert rules configured. What we want to do is to be able to have that as a single pipe to be able to push operation logs information as well as event notifications, whether it is email notification or SMS. Operation logs today that you see in the portal is, again, restricted to storage accounts and cloud services. We want to expand that further to have every single resource that is supported on the Azure platform to be able to push the same operation log notification and information about the date, time, sender, etc., that we can then persist and provide you interesting views over those as well. And with notifications, today it's email. Again, we want to be able to support SMS, push notifications, etc. as well. So that's kind of the what's underneath the hood for the monitoring platform. None of this API is public today. We're looking to make this API public in the next few months. We're working pretty hard to make that happen. There's a bunch of service readiness work we need to do, a bunch of richness we need to add to the previous services we've just exposed to you guys. So we're working pretty hard to get that done in the next few months. So We'd love to get feedback from you as to capabilities that are missing, enhancements that we need to do in some of these areas as well. So with that, just as a summary, the kinds of things that we showed you today, managing your Azure services, Azure applications at scale. So providing a single pane of glass within the management portal and through the REST management API to manage all services in a uniform, consistent, familiar fashion. Providing access through any device, whether it's a tablet or a mobile device, etc. Having notifications and alerts, be able to configure these alerts, be able to receive notifications when alerts are triggered. Providing support for DevOps lifecycle, continuous integration, whether you're using TFS or Git or Mercurial, Dropbox, Codeplex, what have you. Being able to provide a single unified experience to be able to connect to any of these source control mechanisms and be able to push sources of your application and manage them in a rich way within the Windows Azure Management Platform. Providing application health information in a single pane of glass through all different services. Providing support for custom metrics, diagnostics and analytics of your application. Automation through autoscale rules built into the platform across all compute services, and we'll expand this further to other services as well. Providing a single API, whether it's managing your application or monitoring your application, and therefore giving you the ability to not only use our browser client, but also other clients that you want to use to manage these applications. So that is our goal. So at this point, I think we have about 8 minutes left, and we could take questions if you have any. You've probably already attended the session, so I probably don't need to mention that. Yeah, go ahead.
The scaling, when you scale on the virtual machines, it's possible to scale up to a specific machine instead of starting a new one.
So we don't support...
Can you repeat the question?
Oh, sorry, yeah.
So
the question is, when we auto-scale virtual machine availability sets, do we give you the control to specify which VMs are started and which VMs are stopped, right?
I want to scale up the...
One single machine?
So scaling up instead of scaling out. So yes, when I say scale up, what I have actually meant is scale out for people that care about the distinction. We don't today offer the capability to change the size of instances. You can do that in the Azure portal for websites and for VMs. For cloud services, as a deployment time configuration. This is one of the things that we're looking at going forward. It becomes somewhat more complicated if you have those two dimensions to scale on, right? So it's like, what metrics do you define that causes a scale up versus a scale out? So we don't quite have an experience built for that yet, but we will definitely think about it going forward.
It's in the pipeline.
Right. So that's another thing that we're working on. We have, I added those custom perf counters, so presumably you're going to want to do something with them, right? So being able, today you can do alerting on those, but going forward, you'll be able to basically say any metric that you create will be used in an autoscale rule.
Yeah, as you saw in the monitoring architecture, nothing stops us from using the entire metrics pipeline to set up those kinds of rules. So yeah, custom metrics should be possible.
Yep. Okay. So the question is, what languages does the scaling work on? So it will work for any Azure website, any cloud service. Cloud services, I think, are just .NET, but for any virtual machine. And the reason that is because we just look at the raw CPU usage for that box. So no matter what you're doing, if you're using CPU, we'll scale you.
Do you have a way when you're in a large corporation, you have lots of different groups doing stuff to kind of partition the services out so different people have access to different services for provisioning?
You're talking about RBAC in general?
Well, just security on that. So role-based.
Yeah, RBAC is role-based security. Yeah.
Several different IT departments all do different things.
Right. Yeah. So the question is, will we be able to support role-based access control for different organizations or departments to be able to access different parts of the management lifecycle of a given service or applications? So yes, this is in the roadmap for the Azure platform all up. There's a bunch of work that needs to be done at various layers in the platform in order for us to expose this. We are, one of the pieces of work we're doing, I don't know how familiar you guys are with the management platform architecture. Today, we use cert-based authentication for doing all authentication, whether you're doing service-to-service or user-to-service auth. we're moving away from that because it is a big security gap, as you guys might understand, to token-based authentication. That's the big piece of work we need to do before we move to RBAC. So we are in the process of doing that work. As soon as that's done, the next step in the right direction for us is to support role-based access control through the entire platform.
Yeah.
So it's in the works, yes.
For today, the only way to do that would be to break up by subscription each organization inside your company. And then you can have people that manage across subscriptions, and then some people that manage individual subscriptions.
So some people are doing this, though. We've heard this from customers. People are doing this breakup of subscription thing, but that's a workaround for not having RBAC. So we'd recommend for you, if you guys can wait for another few months, we'd recommend that you do.
If you had multiple subscriptions, could you share services between them, like the Active Directory being the big one?
What would you like to share between subscriptions?
Well, we had one subscription that had a bunch of applications used by one group, another one's a bunch, but then we have one central subscription that has like the Active Directory synchronization. Can those other subscriptions access that?
Yes, that you can, yes. Yep. Yes, please.
Is the number of co-admins still limited to 10?
I believe yes. The number of co-admins is...
Is there any thought of increasing that beyond 10?
So because we are moving towards role-based access with Active Directory support and the underlying API support, et cetera, the architecture is going to change slightly, but that then will give us the ability to provide access control in various ways, not just for co-admins. It won't be limited to co-admins or the number of co-admins. So that will change with the new architecture. So
eventually everyone that belongs to the Active Directory group would have
yes,
access.
yes, exactly. Yeah. Yeah.
We have a vertical market web app that's implemented as a web role in a cloud service. Is there any advantage to changing it to a website as opposed to cloud service?
Were you at any of the website sessions yesterday or today?
Well, you say website sessions.
Oh, there were a couple actually. This probably calls out for a couple of them. They may have answered some of these questions. So there is a little bit of as far as recommendation as to what you should use goes. It's a fine line. Websites architecture is moving towards enterprise grade, giving you the ability to have richness in role startup and stuff like that, which web roles today provide and websites don't. But websites are evolving to support some of those enterprise capabilities that web roles do today. And when that happens, we would probably have no distinction, and we would ask people to immediately move over to websites. But today, that's not the case. The two sessions I was talking to you about were the second and the third, and the fourth. If you had not gone there, you may want to look at the recordings. We can also put you in touch with the folks that own the website's runtime.
What would be our motivation if we already have our app listed as a
web role?
service? Yeah, web role.
Today, probably none. But moving forward, when we do have an architecture for websites that actually scaled and supports the kind of flexibility that web roles today provide, then I imagine that you would be building websites and not web roles.
Motivation for moving something that's already a cloud service.
So it depends on how much work you want to do. So one nice thing about websites versus cloud services is they deploy really fast. So a cloud service can take 10 minutes to redeploy, 10, 15 minutes. Scale up, scale down is a lot slower. For websites, it's almost instantaneous. Also, you can change sizes right in the portal. So because of the sandbox model for websites, there are definitely some faster things we can do with management. Whether or not that justifies the cost of switching,
Yeah, it is not an easy, there's no one-line answer to that question right now.
Yeah.
With endpoint monitoring, is there any consideration in the future for allowing us to specify what a custom message, as it were, for like service monitoring?
Custom message or custom CNAMEs?
You send a web request, and whenever it comes back, you're good. But if what I want to measure is end-to-end responsiveness of processing an order or getting a rate, I can't teach you how to send me content for something that's meaningful to my app for responsiveness on the endpoint monitoring capabilities. It's just it's a single message, right? You define the message, I don't.
Yeah, so what some people have done is they have actually constructed a URL. So it's like a URL that will kick off a specific test. So I can create a test page that starts your test internally. But right now, basically all we do pass is that URL. So as much information as you can pack into an URL, that's how much we can run.
But you're asking for additional configuration. That's kind of what you're looking for.
Validating the response. So
Yeah.
if I have a rating service, I need to teach you how to ask for a rate, and I need to validate that what you get back is a valid rate.
Yeah.
That's actually good feedback. I mean, I think we will consider adding that.
Yeah. If you're willing to modify your test such that it returns if an error code, if it actually
Yeah.
errors out,
Sure.
we do. So I didn't show it, but actually, if I like point to a 404, that shows up as down.
Okay.
So a 200 means good. So you can use error codes that way.
You make a specialized web page that does your test.
Yeah.
Returns 200 if it's great, or something else if there's something wrong.
Right.
with it. You put all the logic.
So you mentioned event correlation earlier. That's something we use a lot. We use Splunk. Is that something you have on your roadmap to kind of inject or be able to export directly?
What are you using today for event correlation?
Splunk.
Called Splunk.
Say that again.
Splunk.
Splunk, okay, got it. So it's in the long term, I would say it's in the long-term roadmap. Our first goal is to be able to get the disparate data sources with somewhat of a common schema or a base schema, if you will, in one place for users to get to. That's the first goal. And then be able to provide interesting views over those. And the next step, of course, is for anybody to take that data source and be able to feed it to a Splunk to do interesting analysis.
I guess that's my feedback.
Right.
That's what I'd be interested in is the exporting, because we're
Yep.
not going to have a whole solution in Azure
Yes.
for a long time.
Yes,
So we'd like to see it
yeah,
with the rest of our.
yeah, that makes sense. Yeah, that's exactly where we're going.
It looks like we're out of time, but
Yeah,
feel
go
free
ahead.
to.
We're out of time, but
Yeah.
we have 30 minutes
Yeah,
before the next
we'll be
session,
here
so-
for the next 3 minutes, so
Should I come
feel
up
free to
next?
come up.
Yeah,
Yeah.
go for it, yeah.